Hello everyone, this is Team 3.5 from Bmsce College of Engineering. Our aim is to make a solar charge controller which is cost effective and very simple to use. Now let me run you through all the block diagrams. Here we have the solar panel which is the main source of the power for the entire loads. Solar panel output is not constant, it is varying with time. So we used a regulator buck boost converter to give constant voltage. The charging happens in two phases: constant current charging and then constant voltage charging. Constant current has its own disadvantages and constant voltage has its own disadvantages. By clubbing both, we are able to achieve a effective charging method for the battery. Smart meter is a comprehensive method for the user to peek into the system. Thank you.
Hello, here we are trying to simulate the solar panel using a regulated power supply and trying to get a constant output voltage. Let me get through the circuit components. Here we have the regulated power supply, a section of which is used for driving the MOSFET. The other section is nothing but the solar panel whose voltage can be varied. Here we have the opto isolator. The input section is the controller and the output section is the main circuit which will drive the gate source. And here we have the buck boost network, the heart of the network, the capacitance and the inductance. We give it to a reference load of about 220 ohms, the output of which is fed to a voltage sensor, a portion of which is fed back to the controller. So here the controller senses the output voltage and alters the duty cycle so as to maintain the same output voltage. So here we would test the solar panel for two extremum conditions, a minimum voltage of about 10 volts and a maximum of about 20 volts where standard panels may go about. So as I vary the input voltage, the oscilloscope might show the variation in duty cycle, thereby saying the duty cycle is adjusted so as to get the output. So here we check the input voltage in the multimeter. The input voltage reads about 19.7, which might be the highest voltage panel, and the output is about around 15 volts with a small ripple. Now I change the input voltage to a smaller value. Simultaneously, let us observe the oscilloscope. As you can see, the duty cycle varies, and here we have a voltage of about 10 volts. We again recheck the output voltage in the multimeter. Again it reads about 15 volts with a small ripple. So here we try proving that if the panel goes between the two extremum conditions, the output voltage is maintained about 15 volts. Thank you.
We have seen the buck boost previously. Now let us see the battery charging circuit. Our idea is to charge by two methods: constant current charging method and constant voltage charging method. Let us see constant current charging method. The circuits look like this. The 15 volts that is coming out from the buck boost is divided by a potential divider which is fed to the positive terminal of the op-amp MUS 741. The circuit is over here, the potential divider is over here, and the op-amp is here. Because of virtual short, the negative terminal even have the same potential, and due to that there will be 5 volt drop across the 5 ohms resistance that will drive a current of 1 amps. That 1 amps, due to the transistor effect, that will be same in the emitter even. That then there will be a relay for switching between the constant current and constant voltage method. That will be dealt with later. And there will be a diode which is over here, 1N4007, to restrict the reverse current from the battery to the circuit, rest of the circuit. That is followed, the current, then the circuit is completed using a battery and an emitter to measure the current. Let us see the working of the constant current charger circuit. I have run the circuit, completed the circuit over here. Yes, you can see the current over here, that's reading nearly 0.9. Even the old meter here shows that, as expected theoretically. Now let's see whether the charger battery is building up the voltage or not. Now let's see the voltage across the battery. It's 6.59. You can see that it's fluctuating between 6.59 6.66. It's slowly building up. The voltage of the battery will slowly build up. By this we can say that the battery is being charged by constant current method.
We have seen that the battery was charged by constant current charging method and it can be switched over to constant voltage charging. In this particular video, we are trying to show the transition of the battery from constant current mode to constant voltage mode. Now for that, we are using the 15 volt buck boost bus bar, which is simulated by the regulated power supply of this section, and here we have the battery voltage. Now as the battery voltage keeps building up and crosses 6.8 volts, it switches over to the constant voltage charging mode, for which we use a relay which is powered up by the 15 volt bus bar. The relay contacts, one of which is given to constant voltage charging and the other to the constant current charging, and here we have a regulator which will actually give a constant 6.8 volts for constant voltage charging method. So here I just simulate the battery voltage is slowly increased. Let's keenly listen to the clicking of the relay as the voltage increases above 6.8 around. As it is audible that the relay switches over to the other mode. Now let us check the voltage across the battery, which is given by the relay contacts. So as we can just see, it's about 6.81 volts. By this, we ensure that the battery has switched over from one mode to the other. Thank you.
Hello, we are going to talk about smart meter module now. This is a smart meter module that we have built. It displays the state of charge of the battery, and also it displays the time that the consumer has at the present load condition, and it also displays the system parameters like input voltage and the input current. So far we have seen all the modules. When all the modules put together, we'll have a system like this. It has a solar panel which will source the buck boost. Buck boost will source the constant current and constant volt circuits. Switching between constant current and constant volt circuit will be taken care by this relay, and we have taken care of all the extremum conditions like solar panel when it goes below 10 volts and the batteries goes below the 50% of its total charge. Those conditions will be taken care by these two relays. Since as you see the system is very simple, so hence it will be cost effective and it will be reachable to the lower level of social section.